Recording. Thank you. I don't know if that's what you were saying. These are the backup pins. Back up to the backup. Okay. All right. Recording. And yeah. Okay. All right. Sounds good. So let's see. Black, blue, red, and black, blue, red, green. Okay. All right. Chem 8. Chem 8. Tuesday, Thursday. It's 10/6/2020. Okay. All right. So where are we? Electronic configuration, nucleus, shells, not shell, shells, bunch of shells. Protons go in the center, in the nucleus. Electrons go in different shells. There is vacuum in between the shells. Smallest shell is 1, 2, 3, 4. Within each shell, you have orbitals. Orbitals have different shapes. Well, you know, I told you about taking that information with a little bit of a grain of salt. There are rules to fill up the electrons as we go from a small element to a bigger element as the atomic number increases. Atomic number is the number of electrons or protons. There is Aufbau principle, there is Hund's rule, and there is Pauli exclusion principle. Then we talk about Lewis dot structures of elements and molecules. Molecules form by using single unpaired electrons from elements and different kinds of compounds such as CH4, BH3, NH3, OH2, HF. These compounds can be generated. These shared electron bonds are called covalent bonds, like a cooperative, okay? Both elements are kind of cooperating in making that bond. It's a covalent bond. Valence is coming from both, not just snatching of electron, making an ion. What else? Then we talked about the fact that certain elements, such as carbon, they go from ground state to excited state to make sure that it has enough number of unpaired electrons so that it can make the right compound that we find in nature, such as CH4, methane molecule, not CH2. Then we realized that in order to explain the molecular properties of different compounds, such as CH4, you need to stretch your imagination further and come up with this theory of hybridization. Hybridization produces identical equivalent orbitals, right? We talked about that. We talked about sp3 hybridization for molecules made out of single bonded species. When you get to double bond, something funny happens, and we will touch upon that very quickly and then talk about the properties, and we'll get to a triple bonded species too, and pick up a few skill sets about naming these compounds. Okay, that's the plan for today. So if I write down a few things here, electronic configuration. I'm kind of shortening things up. Okay, electronic configuration is something. Then we heard the word nucleus. Then we heard the word nucleus and shells. Okay, nucleus has protons and neutrons. We didn't talk a lot about neutrons. Shells have electrons. Okay. We talked about different rules to fill up electrons. Off-bow principle. Focus. We talked about Hund's rule. We talked about Pauli. I'm writing fast, so it may be hard to read, but you know what I'm talking about. I'm reading them out so you can figure things out if you cannot read. Pauli exclusion principle. Then we talked about Lewis dot structures. Lewis dot structure. This is not everything, just a guide. We talked about Lewis dot structures. We talked about bond and molecular properties. Properties. Then we talked about hybridization.
Professor, the board is blurry again.
I think it's playing games with us. Looks okay. Yeah. Stay that way. Okay. We talked about hybridization. We talked about sp3 hybridization for alkanes and other compounds like ammonia and all that stuff, right? So this is what we have been talking about. Okay, like kind of like a little guide. So then we talked about CH4. We talked about another molecule, CH3CH3, which is C2H6, and that guy looks like this.
It's blurry again.
Okay. Oops. Thank you. It's not a smart focus. It's blurry again. Is it good? Looks okay? Anybody want to give me a thumbs up? Okay.
Good.
All right, sounds good. Thank you. CH3CH3, and we talked about that, and we mentioned that all these compounds. This compound, this is sp3 hybridization. This is sp3 hybridization. This is sp3 hybridization. Connect a couple of dots together. Whenever you hear the word sp3, you should think single bond. Okay, anything single bonded, single bonded compounds have sp3 hybridization. Not always, of course, not this guy. Hydrogen, this is a single bond, but there is no hybridization because it's using one s electron from here and one s electron from here. So it's ridiculous to think about there is no hybridization here. So you figured that out. But whenever there is a chance that you have two different kinds of orbitals contributing to the bonds, like S and P, if that atom is doing making a molecule only single bonds, then it's sp3. Sorry. I'm getting a notification from somewhere. That's not acceptable. Okay, hopefully it doesn't happen again. Okay, so any compound that has single bond and deals with that central atom deals with has s and p orbitals, then it's sp3, such as this molecule NH3 H2O. Okay, this guy and this guy, they're sp3, 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 sp3. If you cannot read it, whether the board is blurry or just the resolution is low, that nitrogen is an sp3 hybridization, oxygen in water is sp3 hybridization, CH4 in methane is sp3 hybridization, the 2 carbons in ethane is sp2 hybridization. Okay, just a quick background. Okay, so now let's look at this molecule. Let's focus here. Okay, we're going to focus on ethane, go to ethene, and then go to ethyne. Single bonded species, double bonded species, and a triple bonded species, and we're going to investigate that. Okay, that's the plan for first half of today. Okay, so ethane, let's use a different shape, like a circle. These are the electrons from carbon number 2. These are the electrons from carbon number 1. Okay, on the left-hand side, you have carbon 1. On the right-hand side, you have carbon 2. Excuse me. These are the hydrogens. Okay, so that's a CH bond, CH bond, CH, 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 and a CC bond. Okay, there are 7 covalent bonds. They're all covalent bonds, and all these covalent bonds are made from axial overlap of orbitals. I'll just mention it one more time, just in case you have forgotten it. Okay. In a single bond orbitals could be unhybridized orbitals such as 1s, or it could be an orbital such as sp3. Okay, orbitals overlap axially. This is an important word. Axially means along the axis. So they go like this. The overlapping is along the axis, and it produces a very strong bond, producing a strong bond called sigma bond. Sigma bond. Okay, this is not 6, this is sigma. Okay, that's another discussion on the side. So in a single bonded species, that even this, it doesn't matter. So all these bonds, let's just spread them out a little bit. Okay, N and oxygen, and the hydrogen is right there. So this guy, okay, now the first thing that we discussed is that this is sp3, that's 3, number 3, and this is also sp3. All these bonds, all of them, all these bonds are sigma bonds because that happened from axial overlap. They all were formed by axial overlap. Okay, They're all sigma bond. This bond is a sigma bond, sigma, 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 sigma. They're all sigma bonds. As long as the molecule has only single bonds, as long as it's not a double bond, it's a sigma bond. Okay. So we had this discussion. Let's go through it one more time very quickly. If I ask you in the upcoming quiz, what is the makeup of the CH bond? What would you say? What would be your answer? What is the makeup of this bond? Talk. I don't even have the chat open. So don't waste your time on the chat unless you guys want to interact. I mean, yeah, use the chat if you want to discuss something with each other. I'm not looking, so that should give you more privacy. I'm not looking. Okay, what's the makeup of the CH bond? Quick. What kind of orbitals, what kind of electrons are coming from this guy and this guy, the blue guy and the black guy?
One S to sp3.
1s and
sp3.
sp3. Don't say 2sp3. Yeah, that'll confuse everyone. So the answer was 1s and 2s and sp3. Does it sound right to you guys? Say yes or no.
Yes.
Okay, good. Let's move fast. What is the makeup of the CC bond? Quick.
sp3, sp3.
sp3, sp3. Great. Awesome. Okay. So this guy belongs to a hydrocarbon family. Let's use color coding. Let's use color coding. So hydrogen should be blue. Hydro. I love my brand new Expo pens. I'm so happy. See, I'm happy with little things in life. Hydrocarbon. This is the hydrocarbon family. This particular guy is called an alkane. The A is important. Okay, this belongs to the alkane family, and this particular species is called ethane. I'm just capitalizing, uppercasing the A because it's important. Okay, that's ethane. So now we are going to drop to, and you know what? I had a different plan. What was my plan? My plan was to write down carbon 1 and carbon 2 on the two sides. So I'm going to delete these wordings for the timing. I'll write it down a little bit later. So makeup of this bond, we don't have to talk about. Axial overlap, I think it's already in the video. You have already heard it before, but those are sigma bonds. I'm just going to put that sigma here. They're all sigma bonds. Okay, so I need that space. Okay, so the carbon one in excited state, we don't care about the ground state at this point. We need the excited state. 2s1 and 2p3, right? This guy in the same state, 2s1 and 2p3. Okay, in order to make, they need to do some kind of hybridization, each element, each carbon, so that this carbon can have 4 unpaired electrons that are identical. And it needs to do the same deal. This carbon needs to make 4 identical electrons in its valence shell so that it can make 4 identical CH bonds, right? So it mixes everything. So that hybridization is called sp3 hybridization. This guy also undergoes sp3 hybridization to produce 4 identical sp3 hybrid orbitals. Okay, producing, these are the 4 electrons, the round electrons. The carbon 1 also does the same thing. 4 sp3 orbitals, and it has 4 electrons. 1, 2, 3, 4, and all happy, and sigma bonds and axial overlap, blah, 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 blah. And this is the deal, right? sp3 hybridization. Now, when we go to the next species, so this is an alkane, and so where do I write it? Let's write down here. It belongs to the alkane family, okay? And the specific name of this molecule is ethane. Okay, this is ethane. So now from ethane, we move to an unsaturated compound. I shouldn't have used that word. Unsaturated means something that's got double bonds and triple bonds. We will talk about that later. I shouldn't have used that word. Okay. We'll go to the species that has a double bond. Now, this molecule, carbon 1 and carbon 2, will now have a double bond between them. We have discussed it a little bit. Okay. And in order for it to happen, the species had to lose a couple of hydrogens. Okay, the species had to lose a couple of hydrogens because now, if you think about this electron having a little orange halo, it's this electron and it's this electron. So now that's the carbon 1 and carbon 2 have a double bond between them. This is a double bond, not James Bond. This is a double bond. Double bond is that plus that. That's a double bond. Okay, 2 bonds together. That's a double bond, not just this bond. This is one of the 2 double bonds. This is the other of the 2 double bonds. Now, in order for, if I tell you that all these bonds are sigma, 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 and sigma, and if I tell you that this is sigma, axial overlap, the one of the 2 double bonds, sorry, I misspoke. One of the 2 bonds in the double bond is sigma. This is a sigma bond, axial overlap. This bond, the second bond, is not a sigma bond. It happens by bringing in unhybridized p orbitals, the whatever direction, z direction or y direction or x direction. Okay, x direction will be this way, y direction will be this way, z direction will be this way. Okay, so this is a pi bond. What's a pi bond? Pi bond I'm just kind of shortening the number of words, happens by the lateral or side-to-side overlap of p orbitals. Okay, lateral, L-A-T-E-R-A-L, lateral or side-to-side overlap of unhybridized. It cannot, this guy does not tolerate any hybridization. It has to be unhybridized. So I'm going to write down pure. The word pure, it's important. Pure p orbitals. Okay, pi bond happens by the lateral or side-to-side overlap of p orbitals in the same direction. Okay, and remember that in order for you to have a great pi bond, the p orbitals must align themselves perfectly parallel. If it is slightly angled, then the pi bond is a sketchy pi bond. It may not even happen. They must be perfectly parallel with each other. X-axis or Y-axis or Z-axis, it doesn't matter. One of the three p orbitals must be aligning with the other p orbital in the same direction on this next carbon, or it could be carbon and nitrogen, carbon and oxygen, whatever it is. The bottom line is the p orbitals must be perfectly aligned parallel to make a great pi bond. Okay. So coming back to it, we need to figure out the hybridization. We have talked about it briefly in the past. So these three bonds, the sigma, each carbon has three sigma bonds, one with the other carbon and two with the two hydrogens. That sigma bond, and that sigma bond. And this bond is made from a p orbital from carbon, another p orbital from carbon, right? So when you are doing the hybridization for this species, it must generate a different kind of arrangement. That different kind of arrangement, let's use a green color. I don't know why. Let's use a pink color. Okay. Why did I write double bond? I need that space here. Okay. This is a double bond, yeah. So I'll just put it back here. How many pens can I hold in my hand? 1, 2, 3, 4, 5, 6, 7. So this is a double bond. Doesn't even write. It's useless. Double bond. That's a double bond. This whole thing is a double bond. Okay. Sigma bond and a pi bond is a double bond. All right. So now, what kind of hybridization we need to do here? If we do sp3, we make 4 identical orbitals. Okay. We get into a situation like this. We have 4 sticks. 4 sticks from here, right? 1, 2, 3, and 4, and then they take the shape of a tetrahedron. You know that. In the case of single bonded species, that's applicable sp3. In this case, we don't need to make 4 bonds. We need to make 3 identical bonds, such as we need to get into a situation like this: 1, 2, and 3. Okay, 1, 2, and 3. This electron here, this electron here, and that electron here. And we will deal with the pi bond a little bit later. We need to make 3 equivalent orbitals. In order to make 3 equivalent orbitals, where is my pink pen? In order to make 3 equivalent orbitals, here and here, okay, and the last orbital, last p orbital, the pz, 2pz, let's call it 2pz. That 2pz orbital is going to be untouched. Why? Because it's going to be used for making that special bond. Okay. So if we cannot use that, if we cannot use the pz orbital, what kind of I almost said it. What kind of hybridization must take place here to produce 3 equivalent hybrid orbitals? What should you call that hybridization? And how many orbitals from here should go in there? Speak quick, no time. I'm not going to give you for 15 seconds. Hurry up. Speak up, unmute, speak.
sp2.
sp2. It's going to be called sp2 because, simple reason, 1 s orbital will go in the blender and 2 p orbitals will go in the blender to make sp2 hybridized orbitals on both sides, because you just need to make 3 equivalent orbitals to do the business. That last pi bond needs 1 bowl of bean for the little girl who is doing a sleepover with the 3 boys in the neighbor's house. The girl says, I'm vegetarian, I'm not going to eat beef. And the other 3 kids want the chili. So 3 bowls of chili and 1 bowl of uncooked bean. It's that simple, okay? You see, this is why vegetarians have more time to think and do stuff. We should all become vegetarians. I just had some meat, but for lunch. So maybe from tomorrow. We'll worry about it tomorrow, not today. I'm not a vegetarian today. 3 electrons, 3 electrons. Got it? So far, so good. I'm not losing anyone here, right? Just make sure you look at our history so far. This is our historical background, like who we are, where we came from, where are we heading, what is in our agenda, what kind of countries we want to conquer, and things like that, spiritual activities, stuff like that. This is where like some definition of sigma bond, definition of pi bond. We are going from a single bonded species to a double bonded species, okay? And we just figured out what kind of hybridization should happen in a double bonded species. Are we good so far? Any questions? Okay, so I'm taking silence as evidence of understanding. Silence equal to evidence of understanding. Confucius says, when there is silence, people are wise. Most of the time. All right, so we got that down. So let's talk about nomenclature. We are learning something from the future, not from the present or from the past, okay? We are dealing with some of the stuff from the past. We're learning something new right now, kind of. Name this guy. If this is an alkane, and this specific guy in this family of alkanes is ethane, and if this is an alkene, general word, alkene, we have done it in the past. What should be its exact name, professional name? Ethane, alkane, this is alkene. So what should this guy be called? Quick, hurry up.
Ethyl?
How do you spell it?
ETHLENE?
ETH?
L-E?
L?
Yeah. E, capital E, yeah, N-E.
Okay, where did the L come from?
Wait, is it F? I don't know how to spell. Oh, ethylene, right? I don't know.
Ethylene? You're thinking about somebody in life. That sounds more like a human name. Ethylene. Are you thinking about the candies? What's that candy store called? Ethel M? No, something. No L. I'm not mocking anyone. No L. ETHANE. Just change the A to E. That's it. No L. I'm going to put like a huge E so that you get it. You don't forget. You get it, but then you cannot afford to forget. Ethene, E-T-H-E-N-E. It's not a human, so you don't have to make it more pretty. Okay, like ethylene, Irene, Eileen, something like that. L is very common in human names. Molecules, just ignore them. Just give them whatever the dry name. Ethene sounds very dry, I agree. L would have been really good. Ethylene would have been really good. But who cares? They won't complain, okay? Like your niece. Got it? So now we have to talk about their shape. That's going to take up some time. How are we doing with time? Let's see, how are we doing this time? 107, fantastic. Ready? Ideally, supposedly, not ideally, I'm using the word wrong. Supposedly, we saved the 2pz orbital. Okay, let's say this is x-axis. Okay, this is x-axis parallel to the board, and this is y-axis coming toward you. So this is x, this is y, and let's call this direction. I wish my fingers are more dexterous, more flexible. I'm not that flexible. I would never make a good magician. I would probably drop the cards on the floor and people would laugh that, oh, Dr. Maitre is so funny. He's so clever. But, you know, maybe I can convert magic into comedy. X, Y, and Z, okay? So after you put the s orbital and the 2px, that p orbital will be like this, like a dumbbell here and here, right? The y-axis p orbital will be like a little dumbbell here and here, like along this axis. So these two guys and the s orbital in the middle, because we didn't mix this guy, we kept it aside. Okay, I'm going to put it in my pocket. pz orbital, don't touch it, can't touch that. Okay, so you mixed an s and a px and a py, and you got three identical orbitals, hybrid orbitals. They're called sp2 orbitals. I'm not going to dramatize it anymore, more than necessary. When you take three strings attached to a drone, and there are three African bees, I hope I'm not, you know, insulting anyone, or, you know, that's not the whole idea. If anyone is attached to African bees, I heard that there is a killer bee. They're pretty nasty. Okay, even the hummingbirds can be pretty nasty. Now I finally put like a little hummingbird feeder in our back porch. There is one guy who comes and sucks honey from our flowers in the backyard. So we started seeing them, and so I thought maybe we'll give them a treat, the hummingbird feeder. So this guy doesn't allow anybody else touch his food. That's like, it's mine, sugar water, no one can touch it. So the entire day, I think I was going to use the S word, that hummingbird spends most of its energy chasing other hummingbirds. And our son and my wife was saying that, why can't he just share? There is so much sugar water, he cannot finish it. So he has been sucking that sugar water. I think I made about at least like 300 mLs. And it's already almost like done in 3 days. It has eaten up so much. And it's getting lazy because it doesn't go to the flowers anymore. Okay, complete distraction. 3 African killer bees, not hummingbirds. Okay, maybe hummingbird. 3 hummingbirds are tied to the end of the strings. That sounds kind of mean. I'm going to stick back to my African killer bees. 3 African killer bees are here from the central point. And the shape they're going to take, let's cut the drama, planar, and this orientation, 120, 120, 120. What should be the orientation of the z orbital? Well, if this is x-axis and this is y-axis, it's xy axis, the 3 sp2 orbitals will be along the xy axis, and the unhybridized z orbital, pz orbital, will be perpendicular to this plane. Got it? The pz orbital, the 2pz orbital, 2pz p orbital will be perpendicular to the plane that holds these 3 sp2 orbitals, sp2, sp2, and sp2, and this is going to stick out. So if you look at the molecule, it's going to look like this. So one pz orbital is going to look like this. Another pz orbital is going to look like this. Let me see if I have another red one. So the 2 pz orbitals are going to be sticking out and in, and they're going to form a cloud over here and over here. They're going to, the 2 dumbbell-shaped lobes. Dumbbell means like a little, I don't know what to say, like a little dumbbell, like a little round shape, like a cone, and tapered down to the center. and again opening up, and the bottom is the same reflection of the other end. So these two lobes will overlap here, up and down. That's how the second bond, the pi bond, is formed. Don't think, oftentimes our students get confused. They think one of that overlap between the dumbbell, right? This overlap is that, and this overlap is this. No, this entire thing is the second bond, the pi bond. This is the second pi bond. So there is no way you can imagine it. Don't even try to imagine this. Don't try to build an imaginary model in your brain that, oh, the black bond is the sigma bond, and then there's the two p orbitals are kind of doing this lateral overlapping. So we have an overlap on top and an overlap at the bottom along the z-axis from the 0. So that must be 1 and that must be 1. No, the sigma bond has nothing to do with the pi bond. The sigma bond is made from two sp2 orbitals. Axial overlap, that's a pretty darn good bond. This is a completely different story. This guy has nothing to do with that bond. It probably, in reality, it probably has. Okay, so I'm not going to argue with you. If you said, how come that's possible? I give up, I give in, I surrender, and I say, well, I don't know. Okay, so we really don't know. And so this theory with the particles, yeah, I've told you in the past that it's a little sketchy. So when we're learning the theory, you pretend that, you know, this is what it is. We don't have to really pretend, but as long as you take it with a pinch of salt, we are good. Okay. So the bottom line is the set of two carbons, this carbon, I don't really know if I can pull this one off. I have to be really good with my two hands. Okay. Almost there. There you go. Okay. So these are the two carbons, and these are the three sets of sp2 orbitals. Got it? So they come together, right? That's sp2, 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 sp2. Carbon 1 on the left hand, carbon 2 on the right hand. They come together. That's this sigma bond, sp2, sp2 sigma bond. That bond, if I ask you in the quiz, what's the makeup of the sigma bond in the double bond? You should say sp2 and sp2, not sp3, sp3. That's this deal. That's sp3, sp3. This is sp3 hybridization. This is sp2 hybridization. So they come together and then they form an sp2 sigma bond, sp2 1s sigma bond, sp2 1s sigma bond, sp2 1s sigma bond, and sp2 1s sigma bond. Okay, so you pretty much got everything under control, except I can't hold it. I don't have an appropriate model, except for the double bond, which is made from the pi bond happens by the lateral overlap of the pz orbitals. Now you realize one thing, this is very important. Let's see if I can do this, okay? Okay, got it. If this is carbon 1, sp2, sp2, sp2 along the xy axis, and this is the z axis, okay? I can do the same thing over there. I can probably hold this guy here, okay? Just one bond. I can't hold the other two. I'm not that good, okay? Imagine there are two bonds sticking out from my right hand. So as this is happening, as the sp2 sigma bond is happening, in order for the pi bond to happen, the pz orbitals must be parallel, not angled like this. They have to be, their angle has to be 0 degrees. So if they have to be 0 degrees to form a beautiful pi bond, okay, you realize that in order for the pi bond to happen nicely, the entire molecule has to be parallel on the same plane. The sp2 set of orbitals, these three and these three, they must be parallel. They cannot be perpendicular. If they're perpendicular, the pi bond is screwed up. If the angle is not perfectly 0, perfectly parallel, perfectly planar, this PZ and this PZ will go out of alignment, and that pi bond will be all screwed up. Okay, you can actually play with this by making different kinds of molecules where you forcefully turn the molecule and that pi bond becomes more vulnerable to other attacks. So that's how we can prove it. It's all proven. Okay, so the bottom line that I'm trying to, the message that I'm trying to send across is that, once I get hold of my pens, this entire molecule, what color shall I use? I haven't used the purple color. Let's use the green color. So the entire molecule, including the carbons, this entire thing, the carbon 1, carbon 2, hydrogen 1, hydrogen 2, hydrogen 3, and hydrogen 4. This entire thing is planar. Isn't that pretty cool? So the entire molecule across the double bond and whatever the double bond is attached to, those 6 points, you can call it the 6-point arrangement. Point 1, point 2, point 3, point 4, point 5, and point 6. 6 points are in one plane. Make sense? Why? Just because you want to have a perfect pi bond. Just because the pi bond has to be a perfect pi bond, that means the pz orbitals must be parallel. If the pz orbitals are parallel, then the sp2 orbitals have to be coplanar. If this goes out of plane, the pz orbitals alignment is screwed up. It's just like your car's alignment. The two axles in the front, they must be parallel to each other. If one wheel is like that, you will start feeling the unevenness when you're driving. You know, your car is going to probably pull to one side, probably to the right, the way I'm showing it, right? So they must be properly aligned. I'm going to take like maybe a 30-second break. Take a look at the board. I don't think I've erased it, so I'm not going to take a picture yet. I'm going to fill up something here, then we'll take a picture. Make sure you guys are understanding and following what I'm talking about. We're going to go to the triple bond now. Okay. 30 seconds is not done yet. Don't rush them. This has been my lifelong problem. I rush people around me, including my students, poor students. Okay. 30 seconds over. Come on. It must be over. Any questions? Let's go to the next species. So what we learned, when you have a double bond, things around the double bond is all planar, all flat. Okay. Next molecule will be a single bonded species. This got kind of little complicated. I mean, very. Will putting a red arrow be useful? I don't know. So this is where we are transitioning from ethane to ethene. I don't know. It's just too much written here. That's okay. So now we are going to go from an alkene, a double bonded species, to a triple bonded species. Okay, let's do that. Carbon, 3 electrons. We need to make 3 bonds. Carbon 1 and carbon 2, it's coming from the same family. Grandfather, daddy, and this is the baby. Baby is becoming slimmer with time, which is probably a good thing, and more reactive. Okay, CH, you lost 2 more hydrogens. That guy was C2H6, this guy is C2H4, this guy is C2H2. Okay, you're losing hydrogen as you're making more and more double bonds. I mean, more and more bonds. Okay. Let's say Let me ask you a question while I'm kneeling down. You can almost barely see my head. I'm going to stand up. Let me see if you guys can pull it off. 7 sigma bonds in the alkane. 5 sigma and a pi in this molecule. This molecule is called an alkyne. Triple bond. This is a triple bond. Wrong color. Let's make it stand out. How about, I don't know, how about this green color? TRIPLE, not that your video can catch it. So what I just wrote here, in case you cannot see it in the video, triple, TRIPLE, triple bond, 3 bonds, okay? 7 sigma bonds, 5 sigma bonds, 1, 2, 3, 4, 5, and a pi bond. How many sigma bonds do you think the alkyne has? Unmute and answer. What's your gut feeling? I know it's probably not a fully fair question. It's a little unfair question.
3 sigma bond.
3 sigma bonds. Anybody else?
I agree with the 3 sigma bonds.
Alison agrees with Vincent. 3 sigma bonds. Anybody else? One more person. Quick.
Yes, I agree with him. 3.
Thank you. And this is Cheyenne. Thank you. Thank you all. That's a sigma. That's a sigma. That's a sigma. That means the rest 2 must be pi. That must be a pi bond, and this must be a pi bond. Okay? All right. So if that's the deal, if this carbon needs to make 2 pi bonds, that means it needs to save 2 unhybridized p orbitals for doing that funny business. Okay? Z-axis and y-axis maybe. Okay? That's some strange dance move. You can do like a hybridization dance. Okay? And let's say this is your py orbital. I'm changing color to py. Let's say this is your 2py. This is 2py and whatever this is, 2px. Okay. So right now, whatever hybridization you need to do here, oh my God, I just ate up all the space. I'm going to just go down here. Okay. So you need to keep your 2py orbital untouched, and you need to keep your 2pz orbital untouched. You can't touch them to make this pi bond and this pi bond. Okay. So I'm going to just bring them down at the same level. 2pz and 2py. And so the hybridization that you need to do here cannot touch anything on the right side of the green line. So what kind of hybridization will happen here? What will that happen? Why am I drawing it here? What's wrong with me? 2py. To PZ. Okay, so what kind of hybridization will be taking place in this case and in that case? How many S and P will be thrown into the blender? Now there are twin sisters from the neighbors. They're both vegetarian. They want their bean bowl, uncooked, unhybridized, unsauted. They don't want to touch any spice, any oil. Their parents said, make sure your auntie just opens a can of beans and give it to you. We don't trust how they cook. Just have their vegetarian. Just tell them that you're a vegetarian. I'm actually coming across as a really mean and bad person, probably. I'm not that bad, okay? So the girl one and girl two, Susie and Emily, they have their bowl of beans. And Bob and Joe, they want identical food and same thing in their bowls. And the mom says, well, I'm going to make you some chili, okay? Bob and Joe say, okay, mom, that's fine. Just make sure that it looks the same. We don't care what the girls eat from our neighbor's house, okay? So what kind of hybridization will produce just two hybrid orbitals? Speak up.
SP.
SP, that's it. It's that simple. This hybridization is going to be called SP, and each of them will have one electron, and this guy are probably here, SP-SP bond, and this guy here with a hydrogen, sorry, this electron with the hydrogens 1s will form this sigma bond and that sigma bond, okay? So this is it. So this is what SP hybridization looks like. Tell me one other thing. I'm not going to explain this shape of this alkyne. We'll talk about the name in a second. What kind of shape can we call it?
Linear?
What did you say?
Linear?
Sure, why not? We'll call it linear. So this is planar, 120, 120, 120, not exactly, approximately. This is linear. That's simple. It's called linear. Thank you. Got it. Linear. If I ask you, if I'm really like running out of questions to write in the exam number 2, I'm like, what can you ask? I didn't really teach much because of my own problems in my life. I'm always running late. Can I ask you, like, what should be the angle here? What should your answer? What's the angle here? Give you 3 options. 90, 120, 4 options. 90, 90, 120, 180, and 270. A, B, C, and D. Which one is the right answer?
C.
Yep, 180. 180 degrees. Name this molecule, then we're going to take like a minute break and start talking about something different. So this is alkane, ethane, alkene, ethene. This is alkyne. So what should be this guy's name? The grandchild, the slim grandchild. Figure it out. A-E-Y.
Ethine.
Sorry?
Ethine.
Got it. You know what Y reminds me of? If you have to think about a real object, something that you probably played with, probably more so the boys, I'm not stereotyping, but that's the way our society has kind of grown. What does the letter Y, the uppercase letter Y, remind you of? Does it remind you of some object from your childhood or even now? What does it remind you of? Does it paint a picture in your brain? It does to me.
Slingshot.
Yes, got it. Thank you. Anybody else? I used to make my own slingshots by cutting down a branch of a guava tree. I don't know if you know what guava is. It's a pretty crunchy, seedy, wonderful fruit. It's very Asian, I think. I don't know if it grows here. I've seen guava a few times, probably imported from Mexico maybe, or South America. So yeah, it does remind me of slingshot. Thank you. Let's take a little break. I'm going to take a picture. If you have any questions, we can do that. I think we're doing okay as far as our timeline is concerned with our already screwed up timeline. I'll take a picture and then come back to the board meeting. We're going to call our Zoom meetings board meetings. How about that? It sounds really good. We have a board meeting on Thursday at 12:30. Somebody tried to call me. I have no idea who that person is. SP3, SP2, SP. 109.5, 120-ish, 180, not ish. Perfect 180. If you say, well, in between 179 and 181.5, then you are probably hallucinating. I don't know from what, maybe from organic chemistry, but you are definitely hallucinating. This is a perfect straight line. Okay, this one is not a perfect 120 because this is a CC bond and this is a CH bond and a CH bond. These two angles are same. These two angles are same, but these two angles are not same. They're slightly different. This is little puckered, like closed. So this angle is greater than this angle. I don't know what the angle is. Okay, 134. We have about 11 minutes. Let's talk about something else. Let's do a few examples if you guys want it. Before we do that, I can spend 2 minutes on any questions regarding whatever we have covered so far. Oh, I was going to say something. I was going to say that I'm going to invite all 3 classes for office hours from 2 o'clock to 3 o'clock for an hour today, this afternoon, once I'm done with this class. So if you guys have any questions, I need like a 10-minute break, and then we can discuss stuff. I mean, you can even talk about something else. We can hang out, like Tuesday afternoon hangout. It's going to be great. It's not going to be great, you know that. Any questions from here, from what we have on the board? Let's start talking about alkanes, and then maybe we'll get ahead. Okay. If you have no questions, last call. Any questions? No questions? It could either mean you don't care, or it could mean that you're following everything. I don't know which way I should be leaning toward. I'm an optimistic person, so I'm going to pretend that you guys are following everything. Hopefully that's the case. Oh, this is such a nicer pen. It's so much easier to erase. I don't have to like do a workout. Never buy Staples pens. They are horrible. Okay. I'm a dry erase pen whisperer. I can talk to them, I can sniff them, and I can tell which one is which. I don't sniff pens, okay? Don't start spreading rumors that Shantanu is sniffing pens. Sounds really bad. If Fresno Bee has a front page news, the chemistry professor at Fresno State has been found sniffing dry erase pens. That'll be funny. Even I will laugh. Just imagine I get pulled over by a cop because he sees me sniffing something and it turns out to be a dry erase pen. And he just sends it for like forensic analysis. So no, it's a legitimate dry erase pen. It's got organic dye. All right. Hydrocarbon. Hydrocarbon, you know, like if I was not a chemist, and a chemist told me the word hydrocarbon, if he says, what comes to your mind when you hear the word hydrocarbon? I would think like a carbon fiber tank, which is used for carrying water. That's what I will be thinking. Like I'll be thinking something like this. When I hear hydrocarbon, I will think about a tank made out of carbon fiber, a beautiful tank, expensive tank. And this is made out of carbon fiber. And it's got water inside. This is a hydrocarbon. I had normal lunch, okay? I didn't drink anything, including water. So just a note on the side, just to give you a glimpse of what comes to my mind, what happens in my mind. It's not carburon, it's carbon, you idiot.
It's blurry again.
Blurry again, see, when I joke, it doesn't like. Okay, I can't find my cursor. What if someone has a mental breakdown because he or she, professor, cannot find the cursor? Do you think it's possible? Like if you talk to psychiatrists for like who has been a psychiatrist for like 30 years and maybe one incident, the professor was brought in by his spouse and turned out that he can find his cursor. Okay, hydrocarbon. The littlest guy is CH4. I can't use multiple colors. Methane. Okay. Next guy, 2 carbon. C2H6 or CH3. CH3. This is a perfect time to go through the laundry list. It's a very boring laundry list, but after learning the hybridizations and the 3 different types of bonds, single, double, and triple, I don't think we need to learn any more concepts. So let's learn something. I was going to mock somebody else in this building, but I'm not going to do that. Just something to do with memorization. CH4, C2H6, CH3, CH3. If you really want to know what they look like, this guy looks like this. 2D, in 3D, it looks like this. Okay, this guy looks like this. H, 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 H. Something like that. I don't want to draw it in 3D right now. This is called ETHANE. Next species is C3H something. We're going to get there. I know some of you are thinking about, how about a formula? Can we just figure it out without drawing that darn thing? Sure. C3H8. This is called propane. Okay. Gas, gas, gas. Flammable, flammable, flammable. This guy would look like this. Sounds like a train moving. Propane, butane. Unfortunately, guys, you need to memorize these 10 names. Methane, ethane, propane, butane, and so on and so forth. C4, anybody wants to help with the formula? Like a CN, CN, and H, something to do with N. What formula would work? 1 and 4, 2 and 6, 3 and 8, so that we can predict 4 and what? What should be the formula? CNH what? Who is good at math?
For every 1 carbon, you have 2 hydrogens, I assume.
For each carbon, 2 hydrogens. So you're saying CnH2n? That's not going to work. Is this 4?
Oh, no.
Right? It's It's 1 times 2, then 2 more. 2 times 2, then 2 more. 3 times 2, then 2 more. So Cn, H2n, then that's the formula. So what should be the formula of butane without going through that painful journey? Cn, C4, H, how many?
10.
Sorry?
10.
How did you get 10?
It's 4 times 2. So that's 8 plus 2, 10.
Perfect. Butane, then pentane. Oh, this is so interesting. C5H what? All these different colors. C5H, somebody else.
Is it
12.
12.
Anybody knows what comes after pentane? It's 6. 6 is
Hexane.
very good. You read the whole book? What's wrong with you? There's so much time. CnH2n plus 2. C6H what?
14.
Who comes after hexane? It's an H word.
Heptane.
Heptane. C6, C7H16. Okay, time to pump in your gas. What's the gas called?
Octane.
Octane.
Octane. C8H what?
18.
18. Then does anybody know what the 9 is? 9-mer alkane is? Non-N. C9, 20. Finally, the decan. C10, H22. How much time do we have? 1:45. That's it. Goodbye. See you Thursday. Today is Tuesday. Yeah, see you Thursday. I was thinking, what day is
See you
it?
Thursday.
Bye. Take care, guys. So I'm going to share a Zoom link in 10-15 minutes. I'm going to just keep the Zoom on, different Zoom link. Okay, I'm going to share it with all the 3 classes. So be prepared to share your room with others, weird people. Bye, everybody. There was somebody said something in the chat. It's blurry. Okay. Somebody must be very shy. Okay, guys. Maybe I'll see you today or maybe not today.